right, Valerie with I Am STEM Able here. Thank you for joining me. We partner with families and educational institutions to help their students acquire success in their STEM studies. Okay, so this series of videos, a special place in my heart for those who are finished with high school. They've decided they want to pursue a STEM degree, and now it's time to prove to the university that you're ready for Calc 1, which is usually that first stepping stone towards the STEM degree of your choice for most STEM degrees. I've yet to come across a STEM degree that didn't require at least one calculus course. So let me know if there are universities out there where this is different. Please subscribe in case you want to follow along. I'm going to go at a very slow pace. Okay, this is again for those individuals who are preparing for, when I took it, it was called ALEX in my community college where I started my journey towards my math degrees. ALEX placement exam. And I took the same thing when I hit the 4-year universities as well, the ALEX placement exam. I don't want the ALEX placement exam to do to you what it did to me. It adds 1 or 2 extra semesters to your studies and your bill, okay, for school. And it also just kind of chips away at this thought that you can acquire a STEM degree. Don't let it chip away at your confidence, okay? And do not let it chip away at your desire to be whatever it is in science, technology, engineering, and mathematics that you want to be, okay? All right, so without further ado, let's go ahead and dive into the first idea. Oh, and let me just show you. So the book I'm using, it's a very pretty old traditional calculus book. And being that many, I would say, of your community colleges and 4-year universities, many of your universities and community colleges have a very traditional approach to STEM education and math education, in particular, those math requirements for your STEM degrees. And so I think it's wise to pick up one of your traditional math books. There are plenty of other math books. OpenStax, I'm a fan of. Those type of educational resources that provide more interactive approaches to math education. I am all for that. I want to encourage you to look for those more interactive ways of learning mathematics, and I'm all for that. But this video is, in this series of videos, is to simply get you past the ALEX and get you into Calc 1, okay? To brush off some of those algebra skills, because again, in my humble opinion, it is not calculus that makes students drop the course. It is the algebra that beats them down and causes them to want to change their major, okay? No more being weeded out by placement exams and Calc 1 courses, all right? So again, this is just a slow pace, detailed look. This video and this series of videos is probably going, once it's done, will probably help those who are trying to enter their math requirements for their STEM degree fall of 2023, by the time I get done just going through and kind of explaining the ins and outs of some of this algebra that you are required to know before you get into calculus. And it is helpful to know. It's not algebra that you won't see in calculus. Calculus is algebra working, you know, to help you see calculus ideas. And so that's my spiel on what this series of videos is about. So evaluating expressions. When I'm teaching, I don't want to assume that everyone knows what all the words mean when I'm throwing them out there. And so perhaps your placement exam tells you, okay, evaluate the expression. Maybe we're not exactly sure, well, what is an expression? So let's go ahead and be informed about what an expression is, and then we'll dive into evaluating them. So what is an expression? Well, maybe in your K through 12 experience or some attempt at college before, and then you decided, oh, college is not for me, and now you're back. Okay, that was me. Come on now, we're just being real. Maybe you never knew what an expression was, or perhaps you've heard of numerical expressions, fractional expressions, or algebraic expressions, right? And let me just make sure that I tell you, I'm not re-recording anything. We're just going with it. Maybe we'll have a more polished approach when I am not a one-man team here. Okay, so these different types of expressions, numerical expressions, where we have numbers and mathematical operations in between them. This is an expression. This is an expression, right? Fractional expressions. Okay, we just have fractions with math operations in between them. This is fractional expression, right? I've seen in some educational institutions, K through 12 institutions, they'll call them math sentences, right? Math is its own language. We're taking English statements and writing them using mathematical expressions, symbols, operations. Okay, it is a foreign language, and so it's good to be able to look at the English and be able to still see the English when we're looking at the math. Okay, all right. Then you have algebraic expressions that include variables, mathematical operations, numbers, fractions, decimals, right? Our mathematical expressions can get real fancy. Maybe we have more than one variable as we move up through our math education, okay? So those are expressions. So many instructions, they're going to ask you, oh, will you please evaluate the expression, simplify the expression, expand the expression, factor the expression, rationalize the expression, rewrite the expression. Okay, these types of instructions can go on different math exams. And so just knowing what you're being asked to do, okay, these are the expressions that we're working with. Next, expressions are made up of terms, right? How many terms are in this expression? Well, 1, 2, 3, 4 terms in this expression. And so sometimes you may be asked to combine the like terms in your expression or simplify this expression, right? Evaluate this expression. And so we just need to be able to understand, okay, well, what are the like terms? Okay, those terms that have the variables look similar. I have a variable here. It seems to be by itself, but there is a 1 in front of this x, okay? 1 times x equals x. We have one positive x right here, plus the number 1. Then we have a negative 3x sitting right here. And then we have a negative x squared here. So when asked to combine like terms, we're simply trying to simplify this expression, write it in a more concise way so that these elements of our term whose variables look alike, we can combine them. And even here, I could ask you up here, oh, please combine the like terms. Well, we do have 2 like terms. We have 2 numbers here that don't have variables attached to them, okay? And so we would say, okay, 3 and then minus 1, or combine a positive 3 with a negative 1, and we end up getting 2. Well, when we're combining like terms down here with this algebraic expression, we're looking for those variables. Well, we have this variable here. It's got an exponent on it, but these variables have an exponent of 1, right? If we're really seeing what's happening here. And so my variables with exponent of 1, I'm going to combine those. My variables with exponents of 2, I can combine those, so on and so forth. This number right here, if we really want to be detailed, it's a 1 with an x raised to the 0 power. Okay, these are all sorts of little fun facts that I'm trying to throw at you, and I'm not trying to intimidate you, but I'm trying to help you see. Okay, I want to help you see the math here. X raised to the 0 power, that is 1. So x raised to the 0 power times 1, that is 1. So technically, all of my terms here have a variable next to them. The variable is x, is just raised to different powers. X to the 0 power right here, which is x to the 0 power equals 1. Then we have x raised to the 1st power that has That's a part of these terms here. And then we have x raised to the second power. So when you're being asked to look at an expression and combine the like terms, then we're going to go ahead and say, okay, well, this one, I'll leave that positive one here by itself. And then I'm going to say, okay, well, I have a positive x here and negative 3 x's over here, x to the first power. So that leaves me with negative 2 x's to the first power. And then I have a negative x squared. Now, in many of our math classes, we want to be formal and we want to feel and look and sound like we belong. And so you're going to put that variable with the greater exponent in the front, and then organize your variables in order depending upon their exponent, right? And so I will end up writing this as negative x squared minus 2x minus 1, okay? There are other things about this expression that we can point out, but we'll just save that for a later lesson. Right now, we're just trying to understand what expressions are and a few simple ways to evaluate them, okay? So what is the difference between an expression and an equation? Okay, these are questions that I have been asked in secret. People don't like asking these types of questions in the classroom. You know, people tend not to want to raise their hand. I've had situations where I'm teaching in a math class and I'll ask, are there any questions? And crickets, no one says anything. And then I'll say, okay, well, did you understand what I just wrote? Nothing. Okay, if you don't understand, blink your eyes rapidly. People will start blinking, okay? No one likes to look like they don't know. I didn't like to look like I didn't know in a math class. But it's just good to ask all the questions that you need to ask so that you go into the placement exam understanding what's being asked of you, okay? So I've been asked this question: what is the difference between an expression and an equation? Great, well, let's go ahead and look at this. Our expression here, this is our expression, right? Made up of terms. We have an algebraic expression here that we could simplify. Then an equation is just two expressions with an equal sign placed in between them. To just say it very simply, we have an expression on this side of the equal sign. We have an expression on that side of the equal sign. And that then becomes an equation, right? Now we're trying to figure out for this algebraic equation, what value of x makes this equation true, okay? All right, things to think about. So equations are expressions with equal signs in between them. Okay, I'm saying it very simply, all right? You throw an equal sign in there, you have an equation. Take the equal sign away and get rid of one of the expressions, I just have an expression, okay? All right, so let's just go ahead now and work on evaluating expressions without a calculator, okay? Evaluating expressions without a calculator. I have several here that are fun sort of expressions to put on an algebra exam, particularly your placement exam that you are thinking about and wanting to prepare for, so that you can find yourself your first semester in higher ed in a Calc 1 class, okay? So let's just look at a few of these algebraic things to know, okay? So here for part A, we have -3, and then we have an exponent of 4 on the 3. Now, what gets people here and what I'm hoping to help you see is, first of all, I want you to see how to look at this negative, the 3, and the exponent of 4, okay? We can rewrite this as -1 times 3 raised to the 4th power. Now, let's take a look at B so that we can see the difference here. In A, the exponent, and the question here is, where is the exponent applied? Where is the exponent applied? And I'm sorry, every time I tend to write, it looks like my camera gets blurry. I'm on a document camera, which is typically a pretty handy tool to use to teach online, but it can get blurry from time to time, and I apologize for that. Okay, so Back to this. So this is an equal sign here. I don't want to confuse anyone. Looking at the difference between these two. This expression here, I don't have parentheses around the negative and the 3, like I do here in B, okay? And so that makes a difference in my final answers when I'm evaluating each of these expressions, okay? The exponent here is only paying attention to the 3. The exponent here is now considering the -1 and the 3, okay? The exponent here in part A is only going to apply, I don't want to call it magic, though math is magical, but the exponential rule here, 3 to the 4th power, it only applies to the 3. The 4 is only looking at the 3 because there's no parentheses here telling the exponent to apply its exponential rule to both the -1 and the 3 like it is here in B. So for part A, we have -1, oh, I almost wrote a 3, what am I doing? -1 times 3 times 3 times 3 times 3, okay? 3 to the 4th power, 3 times 3 times 3 times 3 times the -1 here in the front. When you look at this in your mind, I would like you to see this, okay? When you look at this in your mind, I would like you to see this. There's a big difference here. Again, -1 not included in what this exponent of 4 is telling me to do with the 3. Here, the -1 is included in what the exponent in 4 is telling me to do. Okay, so we have 3 times 3, we know is 9, times 3 is 27. We're not using a calculator, but 27 times 3, 3 and 7, 21, write down the 1, carry the 2, 3, 2, 6, plus another 2 is 8. So we got -81 here, -81, or -1 times 81, okay? -1 times 81, here's the 81, here's the -1. -1 times 81 is -81. Now here, I have -3 times -3 times -3 times -3, which if I want to break this into eight numbers here, I can say -1 times 3 times -1 times 3 times -1 times 3 times -1 times 3, okay? That's what we're looking at here. So -1 times -1, that's a +1, times -1, well, that's back to -1, times another -1. Now we're back to +1. We're back to +1 here. So here's an idea that's probably already popped in your head, or maybe it hasn't. But if I'm taking a negative number, -1 raised to an even power is going to result in a positive outcome. A negative number raised to an odd power will result in a negative outcome. Okay, I hope I said that correctly. Here we are. This is how we're thinking. This is what I would like you to see. This is what I see when I look at this. Leave a chat in the comment about what you see when you look at this. Tell me another way that you've broken this down to be able to understand what's being asked of you so that your final answer is correct. All right. So -3 times -3, that's a +9, right? This is a +9. And then +9 times -3, well, that's a -27. And then -27 times -3, well, that's a +81. So notice here, these two expressions do not result in the same final answer, okay? This one results in a negative outcome. This one results in a positive outcome. Then this first one, the -1 is not, it's ignored, I guess. So I speak of these numbers like they're actually humans with emotions and they can ignore each other or work together. The exponent of 4, it's only concerned with the 3. It is not concerned with the -1. here, because of my parentheses, the exponent of 4 is concerned with the negative and the 3. Okay, let's keep moving. Now we have a 3 raised to a negative exponent, the 3 raised to the negative exponent, all right? So in this, you want to think, okay, well, I'm going to take the reciprocal of the base here. So instead of 3, I'm going to say 1/3. And then my exponent is going to become positive, still hanging out with the 3, okay? And that's kind of small the way I wrote that. Let me try that one more time. It's 1 divided by 3 to the 4th power, okay? Yes, when I look at fractions, I think of division, okay? That's another connection that everyone doesn't make. And so I'm just throwing out things, you know, when I say things, some things may stick. Some things to you might make the problem seem overly complicated, okay? Glean from what I'm telling you what helps you, okay? All right, so negative exponents, take the reciprocal of the base, and then go ahead and apply that exponent. Instead of being negative, it's now positive, you know, it's now positive to, sorry about Darth Vader there, that's my phone. I'll move it over here. It's now positive and being applied to the 3, still being applied to the 3, but now positive, okay? And so then we're gonna end up getting 1/81, okay? Typically I ask people, do you have any questions about that? If you do have questions, go ahead and place them down in the comments, and I'll do my best to get to them as quickly as possible. Now part D, we have the 3 and the exponent of -4, but they're in the denominator. That's fine, it works the same way. They're in the denominator, but this works the same way. We take the reciprocal of 1/3, that's 3, and now our exponent is positive on the 3, okay? Same way, it's just here, our 3 and our exponent of -4, you can think of it as being in the numerator for part C, okay? That's one way to think about it, that might help you, okay? And then here, it was in the denominator, 3 to the -4 was in the denominator, okay? But it's the same idea, okay? Same idea, take the reciprocal, and then the exponent is positive on the number that it was being applied to originally, okay? For part E, now we have a fraction, and our parentheses tells us that this exponent of -2 is applied to both the numerator and the denominator, okay? If you end up getting a test, and I'm not trying to make the life of faculty and teachers harder, okay, but this has happened to me, and I had a student question me about this, and, you know, I agreed with them. I didn't put the parentheses. It was an exam I wrote, forgot to put the parentheses. And the student was like, oh, you know, I got marked wrong for this, but really, you know, I thought that the exponent only applied to the numerator. Okay, well, I'll agree with you on that. Okay, I'll agree with you on that. And I went ahead and gave them full credit for giving me an answer. I forget how the answer was, only because it was unclear as to what I had wrote right here. It was confusing, okay? And it's okay to ask your instructor or faculty if you don't understand something about what they've written on the exam. It's okay to walk up and ask a question just for clarification purposes. Not every faculty or teacher likes that, but I'm all for advocating for yourself. Now, in the moment, I didn't have the time to try to explain to him, okay, well, then what we're looking at here is 1/3 times 2 to the -2, which is really 1/3 times 1/2 squared, which is 1/3 times 1/4, which is 1/12, right? I didn't have an opportunity to break that down for him or her. It was a guy. I typically get questions a lot by the males in the classroom, you know, but it sharpens you. And it helps you in your exam writing. It's painful and can be irritating, but we as instructors and teachers, we have to be open to ways to refine what our assessments and how we teach and what we say and how we teach it. Okay, we got to be open to that. Well, none of us are perfect. Okay, let's go back to this problem that's properly written. So there should be no confusion as to what the -2 exponent is being applied to. I'm applying it both to the numerator and the denominator. So just for the sake of just being able to see what's happening here, this is what's happening. I have 2 to the -2 divided by 3 to the -2. And with the idea of, okay, I'm going to take the reciprocal of each of these and then go ahead and apply a positive exponent to each of those, you end up with 3 squared over 2 squared. Okay, 3 squared over 2 squared. And then you end up getting 9 over 4, which is an improper fraction. We don't want to leave it in an improper fraction. How many times does 4 go into 9? A whole 4 fits into 9 2 times, right? Because 2 times 4 is 8. And then what is left? 1/4, okay? How many fourths are in 9 is another way to think about this. How many wholes, if my wholes are made up of fourths, are in 9, right? There are 2 wholes if my wholes are made up of fourths in 9, with that 1/4 being left, okay? All right, let's look at F. Another exponential rule that you are going to be expected to know to be able to place directly into Calculus 1 is how to work with exponents. You have the same base, 5 and a 5, but you have different exponents, 5 to the 23rd power in our numerator and 5 to the 21st power in your denominator. The rule that should pop into your head is it's written like this in some math books, not all. Okay, this is what you should know. And I would encourage you to memorize all of your exponential rules when it comes to manipulating expressions, you know, working with expressions, evaluating expressions, simplifying expressions. Memorize these before you take that placement exam, okay? There are several of them. So this one, we're going to go ahead and work. So we see that, well, if I have the same base, then I can go ahead and find the difference between their exponents. All right, so I'm gonna go ahead and erase this rule so that I can go ahead and write what's happening here. So this is 5 raised to the 23 minus 21st power, okay? That's what we're looking at there. And so then I can evaluate this expression even further or simplify it even further. 23 subtract 21, that leaves us with 2, so this is 5 squared. Should you get full credit for leaving it in this form? You may not, depends on the teacher. And if I programmed the placement exam, I would ding you points for leaving it like this. It's correct, but not fully evaluated, okay? This is 25, all right? Okay, now this one, I love G. This one is interesting because there's so many little rich nuggets that you should see when you're looking at this that are going to help you when you get into Calculus 1, just things to know about algebra when you see fractions in your exponents. Now let's start with something simpler first before we do this. I'm going to say 4 raised to the 1/2 power, okay? No negative exponent, and our numbers are pretty familiar. We see a relationship kind of, people will look at this and the relationship that might pop out first in their mind is, well, I know that there are 2 2s and 4, you know, different little things like that. When you're in a panic trying to take a math exam, different things pop in your head, different relationships, right? For me, it was like watching a toolbox of all my math tools just flying by in front of my mind and me trying to figure out which one to grab, okay? So that might be one of the things that flies by in your mind when you look at this, but here's what I want you to see. When you look at 4 raised to the 1/2, how I want you to be able to sort of rewrite this in your brain is the square root of 4 raised to the 1st power. Okay, when you see fractions in your exponents, please understand that what you are looking at are nth roots nth roots, okay? Some root of the number. So here with my fraction having a 2 in the denominator, what I'm really noticing is the square root of 4 raised to the first power. The numerator in this fraction of my exponent, it's going to stick with the 4, okay? I'm trying to mix math terms with just other terms that I tend to have to use in math classes where people will tell me, just tell it to me in words I can understand, okay? So the 4 is going to remain, or the 1, this exponent, the 1 in the numerator of the exponent of 1/2 is going to remain with the 4, and the denominator of this fractional exponent, that is the root that we're taking, right? So 4 raised to the 1/2 is equal to the square root of 4 to the first power, which written many times people don't write the 2 on the square root, and many times people don't write the 1. 4 raised to the first power equals 4. People don't write that. It's implied. It's believed that you should know it, right? With the square root, this is how we typically see it on the calculator, you know, and then a number, we don't write numbers 3 to the first power. Write the number 3. Oh, 3 to the first power. People don't typically do that, okay? It's just something that if you study mathematics, you just know it's there. So now you know that it's there, okay? Any number that I write, you know it has a power of 1, okay? And when I write the square root, you know there's a 2 right there. And so this equals plus or minus 2, okay? This is a whole nother lesson. And my mechanical pencil, I am just not fans of mechanical pencils because they crash when you need them the most. They crash. And so here we have plus or minus 2 as our final answer. So now let's go back to 16 raised to the negative 3/4 power. Well, when we think about it in how to break it up here, then using a root, we know it's the 4th root, 16, and this 16 is being raised to this negative 3rd power, okay? Which simply means 4th root, 16, 1/16 to the 3rd power, okay? Now, I am not going to sit and try to do what is 16 times 16 times 16. If you have a quick way of doing multiplication, such as 16 times 16 times 16 in your head, please let me know. Let me just double check and make sure I got the right answer here. So we got 4,096. So we want the 4th root of 1/4,096. And my pencil is dying. This is not embarrassing, but more so annoying. Let me see if I can get the lead to switch out. And I cannot. So my pencil is dead, can't write anymore, but we're going to go ahead and keep this video. You can go ahead and check to make sure my answers are correct. Leave me a comment if they're wrong. Leave me a comment if you found this helpful. Leave me a comment if you have other ways in which to think about these. The beautiful thing about mathematics is, you know, there's typically more than one way to think about how to get to the right answer. I love math because there's typically a right answer, but it's beautiful when you have different types of learners talk about how they got to the right answer. And so definitely let's build a community of not being afraid to be wrong, don't be afraid to have questions, and don't be afraid of your placement exam when you're trying to get into Calc 1. All right, have a great day.